Hi students, in the last class I explained about irrational numbers and the method of proving irrationality of these numbers by using contradiction method. And I have explained some problems on irrationality of numbers in the last class. Now in this class I am going to discuss some more problems based on this topic. The series problem. Prove that for any prime positive integer p, root p is an irrational number. In the last class we discussed this type of problem. We proved I think root 3 is an irrational number, or root 5 is an irrational number. In this we proved. We are proving the generalized statement now. Now you take any prime number p, then root p is always irrational. You have to prove this. We will follow the same steps what we followed in case of root 3 or root 5 or root 7. Okay. Now you know that first of all you have to assume root p is rational. Here root p is rational, we assumed here. Okay. Then, and as root p is rational, we have every rational number should be in the form of a by b. Therefore root p is equal to a by b, where a and b are co-prime integers and p not equal to 0. Now let us simplify this root p is equal to a by b. We're going for squaring on both sides. We will get root p whole square is equal to a by b whole square. Now this p is equal to a square by b square. Let's go for cross multiplication. A square is equal to pb square. Now by the definition of divisibility, we are writing a square is equal to p into something. That's why p divides a square. But in the problem he has given p is prime. That's why p divides a. Now whenever p divides a, there exists a number some k such that a is equal to pk. A is equal to pk because p divides a. 6 divides 18. That's why 18 is equal to 6 into some number 3. The same way p divides a. That's why a is equal to pk. K can be any number. I will substitute this pk in the equation 1. Equation 1 is a square is equal to pb square. In place of a, I'll write pk. A square is pb square. In place of a, I'll write pk. Then pk whole square is equal to pb square. The left side is p square k square is equal to pb square. I can cancel one p on both sides. The remaining is pk square is equal to p square. Now b square is written as p into something. So p divides p square. As p is prime, p divides p also. Now from 2 and 3, p is a common factor for both a and b. And this is a contradiction because our assumption that a and b are co-prime integers, which we have taken in the assumption part. So hence our initial assumption that root p is rational is wrong. What is wrong means therefore root p is irrational. Here all the steps what we followed are just related to the solution where we proved root 3 is irrational or root 5 is irrational. The same way we followed all the steps to prove the irrationality of root p when p is a prime integer. Let us look into one more problem. Prove that root 5 plus root 3 is an irrational number by using the method of contradiction. Okay. we have to prove root 5 plus root 3 is an irrational number. As we told to use the method of contradiction, first step is you have to take the contradict statement of the problem. That is, root 5 plus root 3 is rational. Opposite statement of the given problem. Here we have to prove root 5 plus root 3 is an irrational number. Therefore, assumption should be opposite to this or contradiction to that. That is, root 5 plus root 3 is rational. Now, root 5 plus root 3 is rational means by the definition of rational numbers, rational number, root 5 plus root 3 is equal to a by b or p by q, anything else. A by b, where a and b are co-prime integers and b not equal to 0. Now, we have two square root numbers here. There are two numbers having roots on the left side. And for the simplicity, what I will do, I will take one number to right side. That is, root 5 is equal to a by b minus root 3. Yes, you can take root 5 also. By leaving root 3 on the left side, you can take root 5 also. Anyone is fine. It's not mandatory. How we will simplify this? We can simplify in different ways. But here I am doing in this way. I am taking one number among root 5 and root 3 to right side. In particular, I am taking root 3 to right side. Now plus root 3 becomes minus root 3. Therefore, root 5 is equal to a by b minus root 3. Now we will go for squaring on both sides. Root 5 whole square is equal to a by b minus root 3 whole square. We have done squaring on both sides. Now here we will use x minus y whole square algebraic identity to simplify the RHS. Anyway, LHS is 5 is equal to here a by b whole square minus 2 into a by b into root 3 plus root 3 whole square. Simply we used x minus y whole square formula, algebraic identity. On simplification, 5 is equal to, this is a square by b square minus 2a by b into root 3, this simplification only. Okay, 2a by b into root 3 plus root 3 whole square is 3. This is the simplified equation. At the end we have, and from this take 3 to left side, or only irrational part will take on right on one side. Okay, here the irrational part is root 3. Root 3 is irrational. This 2a by b root 3 has minus sign here. That's why I will take this 2a by b root 3 to left side and 5 to right side. Okay, minus 2a by b root 3 has minus sign. If I take to left side, it will get plus sign. That's why here 2a by b 2a by b root 3 is equal to remaining all as it is, a square by b square, a square by b square. Here if we take minus plus 5 to right side, it will become 3 minus 5. 3 minus 5 is minus 2. That's why directly I wrote here a square by b square minus 2. Okay, I am repeating this step. 5 is equal to a square by b square minus 2a by b root 3 plus 3. Now this is irrational number is root 3 here in this part. Now in general, for the number which includes irrational number should be on left side. We will keep on left side, better it is. That's why minus 2a by b root 3. Here it has minus sign. If we take to left side, it will get plus sign. That's why 2a by b root 3. Now on the right side we will have a square by b square plus 3. But already this 5 is there on left side. Let me take to right side. Becomes minus 5. 3 minus 5 is minus 2. That's why a square by b square minus 2. Now on simplification, a square minus 2b square by b square. Now from this root 3 is equal to a square minus 2b square by b square into here 2a by b, you have to write the reciprocal of 2a by b, that is b by t. The fraction will be reversed. Okay, 2a by b will become b by 2a. Now 1b we can cancel. Here b square is there, here b is there. You can cancel 1b. After latter we will get root 3 is equal to numerator a square minus 2b square by, here already we cancel 1b, b into 2a, 2ab. We got 2ab. Okay. Now here 2a square and b square all are integers. Let's say this factor a square minus 2b square by 2ab is a rational number. If this is a rational number, this is equal to root 3. Root 3 is a rational number. Okay, we got root 3 as a rational number. This contradicts the fact that root 3 is irrational, because we know already root 3 is irrational, but here we are getting rational number, root 3 is rational number. This contradicts the fact that root 3 is irrational. So our assumption is incorrect. What is our assumption? Root 5 plus root 3 is rational. That is incorrect. That means root 5 plus root 3 is an irrational number. Okay. Only you have to take care while simplifying this part. Simplification should be practiced properly. Let's solve no problem. The generalized one for the previous problem. Prove that root p plus root q is an irrational number by using the method of contradiction. The same steps you will follow where we proved root 5 plus root 3 as an irrational number in the last slide. Solution. Take the assumption root p plus root q is rational. So you have to prove it as irrational. You take the opposite statement. Root p plus root q is rational. Now root p plus root q is rational means it should be in the fractional form. It can be written in the fractional form. Here we are taking the fractional form as a by b. Therefore root p plus root q is equal to a by b, where a and b are co-prime integers and b not equal to 0. Now we have to simplify this equation. What I did previously is I have taken one number to right side. Here also I am taking q to right side. It's not mandatory. You can take p also to right side. Okay. Now root p is equal to a by b minus root q. Let's go for squaring on both sides. Root p whole square is equal to a by b minus root q whole square. Well, left side root p whole square is p. To simplify the right side RHS, we'll use the algebraic identity x minus y whole square. Root p whole square is p. Now by applying the formula of x minus y whole square, the algebraic identity x whole square minus 2xy plus y square. Now here first term whole square a by b whole square minus 2 into first term and second term, that is a by b into root q plus root q whole square. Now on multiplication, p is equal to a square by b square minus 2a by b root q plus q. Now here root q, here second term is having the root term or irrational term. We take the second term to left side. It will become minus 2a by b root q is equal, it will become plus 2a by b root q, and take p to right side. It will become minus p. All the terms in the right side are a square by b square plus q. These are the remaining terms in the RHS, and p to left side you are taking. That's minus p. Okay. See once p is equal to a square by b square minus 2a by b root q plus q. Here this is the irrational part. This term includes irrational part. Take this term to left side. It will become, we are doing two transpositions at once. Okay, 2a by b root q to left side and p to right side. 2a by b root q has minus sign. If we take to LHS, it will become plus 2a by b root q is equal to, remaining terms in RHS are a square by b square plus q, and p to right side we are taking, that's why minus p. Now on simplification, regular simplification, we will get a square plus qb square minus pb square by p square. Now in 2a by b to right side, root q is equal to, it will multiply. You have to multiply with reciprocal of 2a by b, that is b by 2a. Here also you can cancel b and b. Finally, root q is equal to a square plus qb square minus pb square by 2ab. Here also p is an integer, q is an integer, 2 is an integer, a, b, all are integers. That's why this number is also rational number. Okay, here in this fraction, the numbers involved are a square, b square, p, q, 2a, b, r, all are integers. That's why this will be a rational number. If this is rational number means root q is a rational number. This is contradiction, because when q is a prime number or any integer, it should be irrational number. Therefore root q is irrational. This contradicts the fact that root q is irrational. So our assumption is incorrect. What is our assumption? Root p plus root q is rational. Therefore, hence root p plus root q is an irrational number. This way we can, just what the steps I followed are just similar to the proof, similar to the steps which we used in proving root 5 plus root 3 is irrational. Okay. you practice properly the simplification part. Okay, simplification part only practice properly. Let's see on the problem. Prove that 2 by root 7 is an irrational number. It's a regular problem. Assumption is 2 by root 7 is rational, opposite of that given statement. 2 by root 7 is equal to a by b, where a and b are co-prime integers and b not equal to 0. Now on cross multiplication, 2b is equal to a into root 7. Except take a to left side here now. Therefore, root 7 is equal to 2b by a. A is multiplying. If we take 2 left side, it will divide. 2b by a is root 7 actually. But directly we can write root 7 is equal to 2b by a. Okay. Therefore, here 2a and b are integers. That's why 2b by a is a rational number. So 2b by a is a rational number means root 7 is also a rational number. Therefore, this contradicts the fact that root 7 is irrational. So our assumption is incorrect. What is our assumption? 2 by root 7 is rational. That is incorrect. That means 2 by root 7 is an irrational number. This is a regular problem. Okay, prove that 3 by 2 root 5 is an irrational number. This is also a regular problem. Okay. We'll do by contradiction method. The assumption is 3 by 2 root 5 is rational, opposite of this given statement. As 3 by 2 root 5 is rational, by the definition of a rational number, 3 by 2 root 5 is equal to a by b, where a and b are co-prime integers and b not equal to 0. This one, okay, you have to simplify this equation. 3 by 2 root 5 is equal to a by b. Now here actually 3 by 2, you will go for cross multiplication. What you are going to get is, you are going to get 3b. Okay, 3 into b is 3b is equal to, okay, by multiplying these two, 2 root 5 into a, 2a root 5, you get 2a root 5. Now we will take 2a to left side, 2a to left side, 2a is multiplying 3b by 2a, 3b by 2a, root 5 is equal to 3b by 2a. This is the I wrote directly here. Now by simplifying we get root 5 is equal to 3b by 2a. Here 3, 2, a and b are integers. So 3b by 2a is a rational number. Now 3b by 2a is equal to root 5 in the above equation. So root 5 is a rational number. This contradicts the fact that root 5 is irrational. So our assumption is incorrect. What is our assumption? 3 by 2 root 5 is rational. That is our assumption. That is incorrect. It is incorrect means 3 by 2 root 5 is an irrational number. This way you can prove by using the method of contradiction. Let's solve one more problem. Prove that root 3 plus root 5 whole square is an irrational number. To prove the irrationality of this number, first of all, we will simplify this. Okay. Root 3 plus root 5 whole square. I am simplifying this by using the algebraic identity a plus b whole square. A plus b whole square or x plus y whole square ratio. Now a plus b whole square is a square plus 2ab plus b square. Now first term root 3 whole square plus 2 into first term into second term, 2 into root 3 into root 5 plus second term whole square, root 5 whole square. Root 3 whole square is 3 plus 2 into root a and root b is root ab, root 3 and root 5, root 3 into 5, that is root over 15, plus root 5 whole square is 5, but 3 plus 5 we can add, 3 plus 5 is 8 plus 2 root 15. Therefore, on simplifying root 3 plus root 5 whole square, we got 8 plus 2 root 15. Now here, to prove root 3 plus root 5 whole square is an irrational number, it is enough to prove that 8 plus 2 root 5 is an irrational number, because both are equal. Both are equal. On simplifying root 3 plus root 5 whole square, I got 8 plus 2 root 15. If I prove 8 plus 2 root 15 is irrational, automatically root 3 plus root 5 whole square is also an irrational number, because both are equal. Now what I will do, I will prove first 8 plus 2 root 15 is a irrational number. To prove that, again what we followed previously, the same method we will follow here also. Assumption: 8 plus 2 root 15 is rational, and it is rational by the definition of a rational number. 8 plus 2 root 15 is equal to a by b, where a and b are co-prime integers and b not equal to 0. I will go for the simplification of this equation. You can take 8 to right side. Actually, the irrational part is 2 root 15. It has already plus sign. Let's take the other numbers to right side. Now 2 root 15 is equal to a by b minus 8. Go for the LCM. We will get a minus 8b by b. Here 2 is there. You take 2 to right side. Root 15 is equal to a minus 8b by b into this 2 is multiplying, it divides. Or multiply the reciprocal of 2, that is 1 by 2. A minus 8b into 1, a minus 8b by b into 2 is 2b. Therefore, final equation what we got is root 15 is equal to a minus 8b by 2b. Now here also all are integers. A, 8, a and b are integers. Here 8, 2, a and b are integers. Therefore, this is a rational number. A minus 8b by 2b is a rational number. But this is equal to root 15. Root 15 is a rational number. This is a contradiction. This is a contradiction. Because this contradicts the fact that root 15 is irrational. We got this contradiction, so our assumption is incorrect. What is our assumption? 8 plus 2 root 15 is rational. Therefore, 8 plus 2 root 50 is irrational. From that you can conclude root 3 plus root 5 whole square is also irrational. Directly I am writing. Hence, root 3 plus root 5 whole square is an irrational number. Okay, to prove the irrationality of root 3 plus root 5 whole square, we simplified the simplified equation. After simplification, we got 8 plus 2 root 15. To prove this root 3 plus root 5 whole square is irrational, we proved 8 plus 2 root 15 as irrational. That's enough. Actually, because both are equal. Okay, here I wrote some right stuff. Okay, we can have one more line here. That is, root 3, 8 plus 2 root 15 is irrational. So, root 3 plus root 5 whole square is irrational. To prove that 1 by 3 plus 2 root 2 is an irrational number. This one is something like before problem. We'll simplify this first. Okay, we have 1 by 3 plus 2 root 2. That means we have an irrational number in the denominator. In this case, in general, we will go for rationalization. Whenever there is a requirement of division of irrational numbers, we will go for rationalization. Therefore, 1 by 3 plus 2 root 2. Okay, rationalization of denominator. 1 by 3 plus 2 root 2 into, you have to multiply both numerator and denominator with the RF of the denominator. RF of 3 plus 2 root 2 is equal to 3 minus 2 root 2. That's why multiply both numerator and denominator with 3 minus 2 root 2. The product of numerators 1 into 3 minus 2 root 2, that is 3 minus 2 root 2. The product of denominators 3 plus 2 root 2 into 3 minus 2 root 2, that is looks like a plus b into a minus b. You can apply a square minus b square formula. That's a 3 whole square minus 2 root 2 whole square. 3 whole square is 9 directly. 2 root 2 whole square is 2 square is 4. Root 2 whole square is 2. 4 into 2 is 8. That's why 9 minus 8. 3 minus 2 root 2 by 9 minus 8 is 1. 3 minus 2 root 2 by 1 means directly 3 minus 2 root 2. Okay, therefore, to prove 1 by 3 plus 2 root 2 is an irrational number, it is enough to prove that 3 minus 2 root 2 is an irrational number. We'll prove this first. Okay. The same process what we followed in earlier. Assumption: 3 minus 2 root 2 is rational. As it is rational, 3 minus 2 root 2 is equal to a by b, where a and b are co-prime integers and b not equal to 0. Now you have to simplify this equation. Okay, we are doing let's simplify this. Check carefully. Okay, always here 3 minus 2 root 2. The irrational number is at root 2 here. In this equation, irrational number is root 2. Root 2 should be on one side, remaining all should be on other side. But the irrational, the term which includes irrational number has a minus sign. Whatever I will made it plus sign. To make it plus sign, we will take it to right side. Then what I will get? 3 is equal to a by b. A by b. We are taking that 2 root 2 to right side. It will become plus 2 root 2 plus 2 root 2. Therefore 3 is equal to a by b plus 2 root. In general, the term which includes a rational number better have plus sign, but here it is having minus sign. Thus we are taking 2 root 2 to right side. It will become a by b plus 2 root 2. But only rational number should be on one side. Now we will take a by b to left side. That is 3 minus a by b is equal to 2 root 2. Now we will have plus sign for the irrational part. No issue. 2 root 2. 3 minus a by b is equal to 2 root 2. Now 3 minus a by b, 3 is 3 by 1 only. 3 minus 3 by 1. Go for regular LCM. By simplification we will get 3b minus a by b is equal to 2 root 2. Now if we take this 2 to left side, it will divide. That means we will get 2b. Therefore 3b minus a by b is equal to root 2. We are getting. Now the simplification taken while doing any simplification, make sure the irrational part has a plus sign. If it has minus sign, take this term to right side, and based on that you can go for the regular simplification. Now on simplification, directly I wrote here 2 root 2. Here I am not giving, I didn't give all the steps. 2 root 2 is equal to 3 minus a by b. That's what we did is we have taken, as it has minus sign, taken it one to right side and a by b to left side. Therefore 3 minus a by b is 2 root 2. This can be written as 2 root 2 is equal to 3 minus a by b. On simplification, 3b minus a by b you will get. Okay. Now take 2 to right side. Root 2 is equal to 3b minus a by b into 1 by 2. That is 3b minus a by 2b. So find what we got is root 2 is equal to 3b minus a by 2b we got it. But here 3, 2, a and b are integers. Therefore 3b minus a by 2b is also rational number. So 3b minus a by 2b is rational number. As these all are integers, the numbers which involve are integers, this will be a rational number. Now this is equal to root 2. That's a root 2 is a rational number. This contradicts the fact that root 2 is irrational. So our assumption is incorrect. What is our assumption? 3 minus 2 root 2 is rational. Therefore 1 by 3 plus 3 minus 2 root 2 is an irrational number. 3 minus 2 root 2 is an irrational number, means 1 by 3 plus 2 root 2 is an irrational number. This you can prove that. So in this class I explained some more problems related to irrationality of numbers. I hope you understood all the problems and their solutions. Okay. Here take care while doing simplification of the equation you obtained in the respective problem. Be thorough with the transposition rules. Okay. Thank you.